Hey everyone, welcome to the latest Hedera virtual meetup. I couldn't be more excited to be talking about token implementations and the Hedera Hashgraph Consensus Service today. I'm very excited to be joined by our Director of Product Management, Donald Thibeau, as well as Tim McHale, our lead developer advocate. So we have a lot of really cool stuff in store for you today. And please be sure to remember that if you have any questions throughout this event, to ask them in the chat, and we'll try to answer them as we go or at the end of the presentation and demos. Tim, would you like to kick us off?
Sure. So hi guys, thank you for joining us. We've got a very short agenda, but hopefully some points of interest in here. So we're going to talk just high level about tokens in general, the standards that are around, the use cases that we're seeing. I'm going to go through a quick refresher on Hedera and the consensus service in particular, just to make sure that everybody's up to the same level. So I kind of level set there. And after that, we'll go through some more details of what we're doing with the consensus service for token implementation, some of the experimentation we've been doing, and we'll walk through a demo that's a kind of ERC20-esque, and then we'll turn it over to Q&A. So Donald, you're a token guy. I'll turn it over to you.
Sounds good. You know, I don't want to take up too much time from the meat and the exciting stuff that you're going to present, but I just want to kind of share a few of points of our perspective of what we're seeing in tokenization, especially on Hedera. So tokenization certainly is one of the, if not the most innovative thing to emerge from the distributed ledger space. It's allowing individuals to tokenize everything from real estate to digital goods, fungible tokens used to foster payments, and non-fungible tokens used to represent unique assets is really just the tip of the iceberg in terms of the business models that have emerged due to this capability to frictionlessly and with finality transfer these digital assets between participants. I think from our perspective, we've seen these types of use cases emerge in large part from our developer community and the ecosystem of startups that have done everything from tokenize and create tokens for the ability to do things like pay music producers for streaming, like the Tune FM team, to do things like issue stable coins and tokens backed by things like the US dollar. And really, there's been an incredible number of organizations who've explored this use case. But what's exciting to us as well is, we've seen it also from a large enterprise perspective. People are interested in issuing traditional financial assets, issuing those as tokens, issuing tokens representing real estate portfolios, and even exploring the use of central banks for issuing central bank digital currencies. And throughout all of these use cases, our perspective and objective with our technology is to provide an easy and accessible and also fast and secure way to issue and transfer these tokens. One of the primary things we've done to enable that is in any way possible align to some of the standards initiatives that are going on in the space. So first and foremost, the ERC standards and templates for issuing tokens with solidity is one of the most widely used sets of standards like ERC 20, ERC 721, and more. But we've also been engaged with enterprise groups like the Token Taxonomy Initiative, which is working to define a ledger agnostic cross-chain set of standards for token issuance and use. So that's really how we've worked, from the top down, gathering the requirements of the behaviors of a token, how it needs to be traded and for what use case, and map that back to our technology stack. We think that the Hedera Consensus Service as a model for issuing those tokens is particularly powerful from the performance and cost perspective, and that's what Tim's going to talk about. So certainly, if you have a token use case, we'd love to hear from you how it's going, what use case you're seeking to add value to. And hopefully you'll find the content Tim's going to walk through a great way to get started with issuing your own token using the Hedera Consensus Service. So with that, I don't want to take up too much time, and I'll pass it back to Tim to start diving into how we can do that and help you guys do that yourselves.
Cool. Fantastic, thanks, Donald. So what we're going to do now is just run through Hedera, the kind of whistle-stop tour, point out a few of the key discrepancies, the key differences between Hedera and other distributed ledger technology, what the benefits of those are, what the drawbacks, the workarounds, well, you'll see. So as we all know, Hedera is a public network. So we have a main net, which is currently permissioned. And by permissioned, I mean that the nodes are run by our council members right now. A list which is growing all the time. In fact, we announced LG yesterday, I believe, so which is very cool. But big companies. In the future, we do have a path to decentralization, and I encourage all of you to go look at the webinars presented by Dr. Lyndon Baird, co-founder, that explains the steps that we plan to take to get us to a fully permissionless network into the future. But let's stay focused for now. So we have a permissioned network. It has a fixed number of nodes. At the moment, they're run by these large multinationals, and they're distributed geographically as well as distributed in terms of the sectors that they occupy within industries. When we send a transaction to a node or multiple nodes, we can, if we don't trust a node, we can send our transaction to many nodes. The transaction will only be processed once, of course. And the node, once it receives that transaction, assuming it's syntactically, semantically correct, assuming you've got enough balance to do whatever it is that you want to do at that moment in time, then the node will forward that transaction as through gossip. And I'm not going to go into the whole gossip and consensus mechanism today. There's an awful lot of depth there that I'd love to talk about, but we only have an hour or so, and yeah, we can talk for an hour or so at least about that. So nodes talk to each other via gossip. We basically sign states after a period of time when a super majority of nodes have seen a given event containing a given set of transactions, and that transaction that we processed at that point becomes part of the history of our network. So the key thing here with the Hedera node that's different to what we're used to with blockchain and similar implementations is that we do not keep transaction history on mainnet nodes. So when we send transactions to Hedera, yes, the transaction is processed by the node, and yes, of course, it updates the state on that node. So state is mutable. Transaction history is the thing that everybody talks about the immutability of, and we'll address that. Obviously, there are some issues with not having transaction history, and we'll come back to that in a moment. But this is great for things like GDPR and right to be forgotten. You know, you don't have all of this stuff and all of the bloat associated with it as well on your mainnet nodes. The other thing I should say is that the consensus mechanism that we have, the hash graph algorithm, is final. So it's not a probabilistic thing. We're not waiting for an increasing number of block confirmations or anything along those lines. Once we actually reach consensus on a transaction, that's it, definitively. It isn't going to get rolled back. It's not going to change. And that happens at the moment in around 3 or 4 seconds on mainnet. Finality within 3-4 seconds is staggering compared to other systems. Mathematical finality is something that's very attractive to anybody in the money industry, anybody who's not comfortable with probabilistic solutions. And of course, we can do thousands of transactions per second. We've currently throttled ourselves down to about 10,000 transactions per second, depending on the type of transaction. But anyway, let's move on. So what's inside a Hedera node? We've got the services API, and we've got, as I mentioned just a moment ago, the hashgraph asynchronous Byzantine fault tolerant consensus mechanism. This is our kind of chef's, or should I say Lehman special sauce. Each of the different services use that underlying hashgraph consensus mechanism. So any transaction that we send to the network, whether it be an account transaction, a contract, or a file transaction, or consensus, which is the thing that we're really here to talk about today, they all use the exact same consensus mechanism. And really, the consensus mechanism, the consensus service was given the same status as the other services, precisely to allow everybody else to use that underlying transaction mechanism without being constrained by a predefined service that the distributed ledger kind of community had consolidated around. So the idea is you can build your own services using consensus. So when we send a transaction in, irrespective of the service, it's pushed into an event. The event's gossiped with other nodes. As soon as we reach consensus, then local state's updated. We can generate state proofs. which are portable mathematical proofs. And at that point in time, as soon as we've hit that consensus, it's definitive, it's there. Now, I mentioned that we don't keep history, and of course that can be problematic. If it's great knowing that your bank balance is X, but if you don't know why it's X, what the transactions were that led to it reaching that point, then it's kind of confusing. So for that, we added what we've called Mira nodes and the Mira nets. Now, the Mira node code is already in the GitHub repos. It's already open source. Anybody can run a Mira node right now, and several of our community members are already doing so. I'll use one as part of the demonstration later just to show you some things. But Mira nodes are kind of like mainnet nodes, except they're read-only from a consensus perspective. They don't participate in consensus, but they do see all of the traffic that mainnet nodes see. So as soon as my transaction I send to the network reaches consensus, then Mira nodes absolutely know about that. And it's up to the operator of the Mira node, or the Mira node, sorry, to determine what it is that they want to do with that, whether they want to forward it, whether they want to keep it, store it, change local state, etc. So this is our means to allow selective persistence of transaction history based on use cases. And there are all sorts of use cases. You could give your regulator or your auditor a Mira node and let them see everything you do, or you can be granular about it. And maybe Mira node as a service or keeping my history as a service becomes a thing into the future. So what's inside a Mira node? Well, first of all, there's a subscription model. So we can subscribe to a topic, and I'm going to be talking about topics a lot tonight. This is the consensus service. Consensus service, the only thing in state with the consensus service is a topic. And that's a bit counterintuitive, and I'll come back to it. But fundamentally, think of a topic like a queuing topic, a Kafka topic. It's a channel within a channel, or it's a hashtag, if you want to think of it that way. It's a way of segregating data and distinguishing flows of data between for different purposes, let's say. So I can create a topic for my particular use case. I can subscribe to that topic after that. So and so can the other people who want to participate with me on whatever it is we're doing. And when something is published to that topic through this subscription mechanism, which is a gRPC subscription mechanism at the moment, they'll all be alerted to that change. So once we've subscribed and a message is seen by a Mira node, you can filter it, of course. You can decide whether to store it, and you store the transaction history, and you can publish that back out to everybody who's just subscribed, as I just stated. And this process adds a little bit to the round trip. We've added some delay into the demo. I'll show you in a little while. So there's maybe a 5-6 second delay in here. But what you've got to remember is that for every transaction, then let's go to an example. If I take Alice and Bob, some cryptographic examples here, and Alice wants to send a message which she knows Bob is going to see. She's sending it to Hedera node. The Hedera node is gossiping that out to the other nodes, and we've already said that it takes 3-4 seconds for that consensus to be reached. Then the Miranet node is going to push that back out. It's going to see that and push it back out through the gRPC subscription. So we're talking maybe 5 or 6 seconds. We'll see in a moment. And of course, the benefit here is that Alice will see her own message come back, so she knows that it reached consensus. And similarly, Bob can do that. And quite often, we have a kind of ACK process, and we're not going to do this in the demo that I show you tonight, but this is kind of a common thing that we do when somebody sends a message. You send a message back saying, yes, I saw your message, and therefore it's logged through Hedera that that message was seen by that participant. Okay, that's just a teaser slide. Sorry, we can ignore that for the moment. That's some other work that we're doing about integration with other queuing technologies. But this is the token related piece. And again, I don't want to spend a lot of time talking about this slide in detail. It's really the right-hand side of this that we're going to talk about now. But fundamentally, there are efforts going on. Of course, IBM's on our council. Donald's heading up the initiative to integrate with Hyperledger. There's all sorts of benefits that we can share in terms of using a Hyperledger or a Corda or a Quorum network through Hedera for consensus. And the key thing here, again, we've got Hedera fair timestamps. So irrespective of which of these platforms, any of these platforms, or any of the queues that I just showed you on the previous slide, irrespective of where the transaction originates, everything gets one single fair timestamp. And by fair, what we mean is that the transactions are passed to all of the nodes effectively, but a minimum of a supermajority. So let's say more than 2/3. And then we look at when each node saw that transaction. We take those times, we put them into a big long list. And once we've got that list, we pick the median timestamp, so the middle one, which means it's very, very difficult for anybody to influence that timestamp. And this is a mechanism, it's a mathematical definition of fairness that we believe is the correct way to do this. So that's the kind of intro. What I'm going to talk about in a moment is the Hedera native implementation, where we've got a very simple state model and some business logic. There's some comms and crypto that talks into Hedera, and you'll see that all of these blue arrows go into the kind of central piece, which is the Hedera mainnet, and all of the magenta arrows come out of the Mira net, so from the Mira nodes. So that's the kind of pattern that we're going to see a lot. I will say that we've got a lot of different examples for a lot of different purposes. We've been churning out example code recently to show to different people in different industries. There are some more complex demos than the one that we're going to show you tonight that do a lot more, but we've deliberately kept this kind of down to a minimum because we want it to be as understandable as possible, as digestible as possible. And once you get your head around this, and it's not difficult, believe me, once you get your head around this, then there's all sorts of other stuff that we can add around here in terms of hashing, encryption, signature of transactions for kind of discretionary proof after the fact. And that's something we will talk about maybe another day. So I think I'm going to pause just for a moment. That was kind of my level set on Hedera. Is there anybody kind of shouting out in questions saying, I don't get it, there's this big issue, I don't understand? Because if there is, maybe we should address that before we dive into demo.
I don't think we have any pressing questions or people yelling at us in the YouTube chat, which is probably a great sign. I would just recap that there are a lot of different ways that you can do tokenization on the Hedera Consensus Service. This diagram really nicely shows that you have the option to integrate with any type of private ledger or permission network that's out there, as well as what we'll be talking about today, which Tim said, which is ways to do native tokenization on the Hedera Consensus Service. So, while we'll be diving into a specific example of an ERC20-like token that's built on Hedera natively, there are a broad set of ways using, existing ERC standards, the Token Taxonomy Initiative, or others in coordination with the awesome tooling and services provided by Hyperledger and Corda and Quorum to help you along the way in your development journey. So while we'll dive into one of these demos, we do, to Tim's point, have a variety of awesome ones out there that we highly suggest you looking at and utilizing depending on your use case and business needs. I'm going to double check and make sure no one's yelling at us in the YouTube chat. Again, folks, if you're watching this live, please let us know if you have any questions. But it looks like we're all good to maybe dive into the demo, Tim.
Cool, that went faster than I expected. So let me just stop sharing this. He said, there we go. We should hopefully see some much less pretty things now. I'm going to move people's cameras out. Right, there we go.
Much less pretty, but much more exciting, Tim. Don't worry.
Yes, this is the more interesting side of things. So what I've got here, and I'll point you all the link later to this repo, but I've got a local copy of one of our open source repos. There are some hidden files in here. I've opened one of them just to kind of highlight it. So we've got this operator ID. So this is a .env.sample file or .sample.env. I forget now since it's hidden. So yes, it's .env.sample. There we go. And before you can use this, of course, you do need to go and put some details in here. So you will need an account on our testnet. You need to put your account number in as operator ID, and you need to put your private key, which is the reason I'm, of course, showing you the example rather than the one I've already updated, although this is only testnet. But the third line set for you, just pointing at a Mira node right now. So once you've got this file set up, you're in a position to run these demos. I've already gone through the build process. It's really, really simple. I'm not going to go through any of that. It's fully documented in the repo. But what we want
I
to
did
do,
the build process before this call, and I think it only took me like 2 minutes, which was pretty sweet.
yeah, it really is. It's unless you've got some kind of incompatibility or something, then it takes no time at all. And that usually happens to me, and it didn't this time. So yeah, I was very pleased with that. So what we're going to show here is just a standard mechanism for creating new tokens. So we're going to define a token effectively. Donald mentioned earlier that we've been talking to the TTI, the Token Taxonomy Initiative. I was delighted when I found their model. So the TTF, the Token Taxonomy Framework, there's an awful lot of work been put in by those guys. There's some really cool definitions in there. However, it's way overkill for the kind of demos that we're trying to do at the moment. There's a lot of complexity, and they're really doing some great work in avoiding a lot of the problems that might come out of diverging standards, let's say, into the future. So what we've tried to do with all of our token demos, for that matter, is to take that TTI, TTF framework and use the necessary subset of it. And it is a cut down version that we are kind of just using. We're scratching the surface really at the moment. But everything hopefully will comply. And for those of you who know that stuff, then hopefully this is going to be fairly, what's the word I'm looking at? It will look very familiar, let's say. So
yeah, and anyone coming into this demo from the Ethereum world, the Solidity world, should be pretty familiar with what we're going to showcase here. What it really is, and Tim might be talking about this as well, throughout the demo. But this is really a mapping of the ERC20 standard onto the Hedera Consensus Service, which showcases how, if you're familiar with those types of tooling and infrastructure, kind of the use case of an ERC20 token, a way that you could implement and leverage that on the Hedera Consensus Service. So to Tim's point, the TTI and the Token Taxonomy Framework has a broad set of implementations that can all be implemented in the same way, that can give you the different types of tokens that you're looking for, non-fungible tokens, different types of governance tokens, tracking tokens, reward tokens, almost anything that you want to build can be implemented as part of this framework. And so I'm really excited that we have this kind of stripped down ERC20-like demo that we're going to showcase now.
Yep, it is stripped down. It's very kind of deliberately simplistic, but here's one I prepared earlier. So what I'm going to do, I'm going to construct, and this incidentally is just a fungible token demo. Oops, and it helps if I can spell right. In fact, maybe I should just do that. Right, let's call this Meetup Token 2, because obviously I ran a test earlier. Right, MT2. Okay, so what I'm doing here, I'm constructing a new token. This is the name of that token. So I've called it Meetup Token 2. This is the symbol for that token in this case, and this is the final parameter, the 2 in this case, is the number of decimals that we're going to have on this token. So if I were to mint later 1,000 tokens, then I'll have 100,000 of these fragments, the decimals. So let's do that. So here we go, and you'll see at some point imminently that there's going to be a JSON file pop up in this window. I'm hoping. There we go. All right, so this is my testnet account ID that you can see here, and this is a JSON file. Now, we in the last slide, which I probably should have gone through in a tiny bit more detail, we talked basically about some state, some business logic, and some comms and crypto. And the state, of course, is whatever's held locally by the participant, commonly referred to as a node in DLT speak. I'm going to call it a participant here, just to keep things separate, because I don't want to get confused between Hedera mainnet nodes, Mira nodes, and now our token nodes, or whatever we're going to call them. So basically, each participant here has a copy of the state. And the state in this case, I told you we kept it simple. The state here is this JSON file. So that JSON file is everything. It is my database effectively. And if I switch to this and just hit refresh, then we'll see that there's not a lot in it at the moment. So we've got a lot of not very much. You can see that it's given us a topic ID, which I'm going to copy here just for a moment. And I mentioned a third-party explorer on Mira node earlier. We're just going to look at Kabuto here. I'm going to paste in my topic ID, hit enter, and we should see that there's not very much happening on this topic at the moment. We've had a single message. Let's go have a look. There's a lot of crypto stuff in here just because these messages are all signed. So the way that this demo works, we're using the signatures associated with the Hedera account. So if you've got a Hedera testnet account with a public key and a private key, when we exercise a token primitive here and construct as a primitive in our parlance at the moment, so when we sent that, we signed that entire transaction with our private key before we sent it to Hedera, sign it again, sending that transaction to Hedera with a private key. So this is kind of twice signed with the same key at the moment, just for simplicity. In reality, we'd normally use different keys for that. But that what you're seeing up front here is the signature. These messages are Protobuf messages, so they use Google Protobuf, so they're a little bit hard to read. But hopefully down here you can make out that we've got Meetup token number 2. We've got MT2, which is well, you can see up here the name, and we've got a number 2 right at the end. So that's the capturing that piece of those pieces of information, and that's now been through Hedera. It's logged on this Mira node and any other Mira nodes that's listening to this topic right now, and it's there permanently, or until this Mira node crumbles into dust. So now we've got a token. We don't have any instances of that token yet. We haven't created any. So let's do that. So again, let's say, oops, let me just copy that again so I don't have to do it every time. I will do a refresh here incidentally. So we're relying, this demo is kind of simplistic. So we have to kind of query it after we've done something. So we send something to Hedera. We've sent, in this case, the construction instruction or primitive. And now if I just ping this, it's going back through the Mira node asking for that information. As soon as it's done that, I'll hit refresh and we'll see we've got a little bit more information now. So let's just go through what we've got here. So we know we've got a token supply of 0 at the moment. We haven't minted any. The token symbol is MT2. The name of the token is Meetup token 2. We know we set 2 decimals, and now we get into addresses. So this is the addresses that are known in this particular token implementation. So this should be pretty familiar to those of you who are ERC20 buffs. It's very much the same type of technology. We have this is my public key, and I am the owner of this token because I've created it. The public key is also the same as the name. We were going to give them discrete names for a while, but decided not to do that just for simplicity again. And there are no allowances or anything set up. So this is pretty basic at the moment. There's a single operation, which was that signature that we looked at in Kabuto a moment ago, and that's the signature of that first construction message. And finally, we know what the timestamp was of the last message, the last consensus, and the nanoseconds associated with that. And this is the Hedera Consensus topic ID. So basically, anybody else who wants to use this token would have to talk on this very same topic ID. And that's like a private channel. Topics can be permissioned in that we can have submission keys, so we can have a way of controlling who submits messages to topics. But in this instance, we'd expect anybody to be able to participate in this token, in this topic, sorry, if they want to use this token. So
this makes a lot of sense so far, Tim. Just to kind of pause here and recap, we're kind of using this JSON file as like your local copy of the database to show the history or the state of this HCS deployment. Is that correct?
That's exactly correct. Yeah. So
when you run that refresh command, it's basically just updating that local JSON file to get the current state of the history from Hedera or from a Mira node.
That's correct. That's exactly correct. And it could be, at the moment, this is pretty simplistic. We're just querying that one Mira node. We could, of course, be querying many Mira nodes. We could be doing all sorts of cross-validation to make sure that all the Mira nodes give us the same answer. There may be malicious Mira nodes out there in the future. Let's hope not.
That makes sense. I think we have a question in the chat here, and maybe this is a good one for Donald. Someone asked, if a Mira node is down for, say, 24 hours, what process would they follow when reconnecting to the network or maybe even other Mira nodes?
Yeah, that's a great question. Currently, we have the beta version of the Mira node, which will soon be rolling out for operation by a greater set of the community. And that architecture uses something called a stream of records from the mainnet. Now, those records are stored in a distributed set of buckets in different cloud providers. And so a Mira node would simply reconnect and download that data for their Mira node. As we move to the full Mira node, where it's actually participating in gossip, with mainnet nodes, that migration process will change. And that's something that documentation and operating process would be updated as the software is released.
Sweet, that sounds like an exciting release. I know that there's been a lot of hard work on the Mira nodes, and if anyone wants, the code for those is really great and a great example of all the hard work that Hedera puts in to their project. So that's a great kind of showcase of the quality of software Hedera is familiar with. We did have another question. What's the difference between Theta and Hedera? I don't know if Donald wants to take this one as well.
Yeah, sure. I'm obviously only, recently familiar with Theta, but, my understanding is they're more focused on video streaming on distributed networks. We certainly can provide types of value to those same applications for gaming. For instance, if you want to use the Hedera Consensus Service to log actions in, say, a gaming marketplace or another MMORPG, HCS could be well suited for that. But I think, Theta is really just focused on that video streaming, but it certainly seems like they're doing some exciting stuff as well, but might just be focused on a different set of use cases as Hedera.
Yeah, I got a brief glimpse of it, and it seemed to me kind of be like a peer-to-peer content delivery network, kind of like a Cloudflare or something like that, where it's really focused on that video vertical, where Hedera is very much applicable to just about every industry that's out there. So that's a great question as well. If anyone else has additional questions, please keep putting them in the chat. But Tim, let's go back to the demo. And
just on that subject, so in gaming terms, there are high value assets in games. You get the mystical sort of I don't know. I wish I hadn't started that sentence now. But you get some very high value asset. You can tokenize those assets, right? And you can exchange them using exactly the same process as we're doing here. So these are fungible tokens at the moment, which are not uniquely identified. They're just like coins in your pocket. You can't tell one from another, but they have the same value. With non-fungible tokens, you absolutely can have a unique identifier for each given asset, and in-game assets are another use case of that. So it applies very directly to this demo as well. So where was I? I was trying to copy something from I got distracted by the question.
I think you were about to mint your tokens in here.
That's right. So I'm just trying to save myself typing out that long Java -jar command every time, because I'm bound to mess it up. So let's mint some tokens. Let's do a different number this time, just to make things interesting. I'm going to mint 99,999 of my Meetup tokens, Meetup 2 tokens. I hit enter, and off we are minting. So what's that mean? What we've done here, we've kind of created a model that we're now creating instances of. So this means there are now a total of 99,999 tokens divided into 100 parts each. So there are, I'm already losing it, but yeah, there are 2 zeros on the end of this. And if I do a refresh here, and then we've got a notification from the Mira there, and we have a look, we'll see that another operation appears in here in the moment, but that's the mint operation that we just performed. And we'll also see that some changes have happened here. So let's do that. Okay, so now we can see we've got 99,999.00, or 9,999,900. They are currently held by me, the owner, as I've minted them, and that's it. There's nothing else. The other thing, the additional operation is in there. We can go back to Kabuto. If I go back and look here, and any Mira node that was watching this topic can do this. We'll see that there's a second message here. Can look at this, and yeah, here we are. We've got some more data here. It's got some long keys in it that are the keys that we used to authorize this. And I'm trying to see if there's any numbers that I can make meaningful out. I don't think there's anything really readable in there that I can take. Incidentally, the Protobuf messages, if anybody's interested in the definitions of those, I do have. They are in the repo, but you can see the exact kind of definition of these and the things that I'm typing. So when I did the construct, we had the name, symbol, decimals. When we had mint, we had the address that was minting them, and the quantity. and we've got some other things that we'll look at now.
And anyone familiar with, ERC standards should be able to see how those protobuf messages and these functions, mint and so on, that will keep going throughout this demo, should be able to see or really understand how easily this maps to that kind of world and background that they're familiar with. That was really the goal of this demo. Like we said, you can implement all the types of tokens that you would want from the Token Taxonomy Initiative and other standards. But this is really just a way to kind of showcase what people are most familiar with, which is the ERC20 Lite token. And compared to something like Ethereum or some of the other public networks out here, even in this very minimal implementation, where he's just updating and querying from a Mira node and updating his local JSON, you can see how much drastically more performant it is than waiting for something like an Ethereum block to be mined. That mining might not include the transaction that you added. You might have to, bump it with additional fees or, resubmit it. And so this is a really great kind of demonstration of the efficiencies that are enabled based on these types of architectures. So it's really cool to see. While we're here, I have one more question, maybe for Donald as well. If we're talking about gaming, which is an awesome use case for different types of tokenizations, especially non-fungible tokens, will Hedera ever release a C# SDK that would be compatible with Unity or other game development engines?
Sure. So let me just take the opportunity to give a little bit of detail on our road mapping. Generally, we solicit input from the community, our users, and the council members when determining how we prioritize things like different language SDKs. So that's resulted in us having currently a Java, Golang, and Node.js SDK available for all of the Hedera services. There's also a number of community efforts to build other language SDKs, but hearing that there's interest is really the best thing you all as a community can do to help reprioritize those things. So it's certainly something we can consider in the roadmap in the future. And of course, if there's a community member willing and interested in helping to build that, we'd certainly support that effort however possible.
Yeah, and that's a great reminder that this demo is built entirely in Java, which is, one of the best things about programming on the Hedera Consensus Service. You can build that application logic in, any of these supported languages, or even build your own SDK to support the languages that you would like to use. So instead of having to, be familiar with Solidity, learn an entirely new development paradigm, or in a space where it seems like teams are coming out with new smart contract languages every couple of months, it's really nice to be able to create these types of tokens using existing frameworks and toolkits like all the ecosystem around Java. So great question, and thank you for asking. If anyone has questions, please keep putting them in the chat.
And there is a .NET community SDK out there. I'm not sure quite where we are with feature parity there, but shout out to, I think it's Bug Bites that runs that. So thank you very much for all your hard work. And yeah, one more.
I believe it is fully up to date with the official SDKs, at least to the best of my knowledge. So awesome work to Jason and the Bug Bites team.
Yep.
But let's keep going. I think I'm actually going to be able to connect to this topic, and maybe we can send some tokens back and forth, Tim.
Yep, absolutely. So look, the first thing I'm going to do, that's your private key. Your public key. I hope it's not your private key. And what I think I'm going to do to start with, I'm just going to try and send you too many. Right. So there's obviously not that many. I haven't minted that many. So I'm going to try and transfer that many. Incidentally, these statements, I'm not making this clear, but when I hit transfer, when I type transfer here and I put that that destination public key, the source public key is implicit, right? Because it knows it's me. It's looking at that JSON file. It's looking at my environment file. So that's how it knows it's me. For some of these commands, it is necessary to put the source key in there as well. But for the vast majority of them, you can take it as assumed. So that's why you're not seeing more public keys bandied about here. But anyway, let's try and transfer a veritable fortune of Meetup Token 2s to Cooper. Off we go. I don't think we'll see any problems with that until we try and refresh. And what happens when we try and refresh? So this is where I mentioned on the diagram, the last diagram in the deck, we mentioned the business logic. Well, of course, if you think of it as any token model has business logic, you cannot spend more than you have. You cannot transfer more than is in your account. These are business rules associated with a simple state machine. So all of this is implemented in the Java code, which you're all welcome to go and look at afterwards. And if I refresh here, you'll see that the account now, so this is now aware of that public key. So and it's not an owner public key here. So we know this is Cooper, but it's not obvious from here. You can see there was another operation that went through, even though it didn't succeed, but it's there and logged. Let's try that again, but let's do something a bit more reasonable. Let's transfer, let's say 10,000. These are the fragments, the cents, if you like, of the token, as opposed to tokens in their own right. So if I do that now, and again, once that's happened, I'm going to do a refresh. And yeah, the time here that's taking for this to happen, I think I said 6 or 7 seconds earlier. I'm not sure if that's accurate. If somebody's there with a stopwatch, maybe it feels nearer to 10 at the moment to me, but certainly in that order of magnitude. Now, if I go and look at my local JSON, then hopefully I'll see, oh, my balance has gone down. All right, so in here we can see there's less than there were, and all of a sudden, Keeper has well, it's 100 tokens I've actually sent him, so 10,000 token cents, and yeah, we can transfer more. So I don't know. I can go through quite a lot of these. I've got a stack of these commands. We can do simple stuff like let me grab I don't know if you want to transfer some back or something, Keeper. If you want to try. In the meantime, there are lots of kind of query commands in here. So we can do, for example, what's the name of the current token? And hey, we know it's Meetup Token 2. We can say, what's the symbol? So there's a way of querying the Mira node or Mira nodes to get this information. And this is really the mechanism that's used to refresh that JSON file. We can do more complicated things. You know, we can say, what's the, let's say the total supply. Yeah, and there we go. That's the total supply in circulation. So there are a bunch of different commands, which again should look pretty familiar to those of you who've worked with tokens up until now. And I confess I'm not the token head in the crowd here. We also support allowances, so allowing an account to spend on our account up to a certain threshold. There's some commands in that support that. So setting allowances, increasing, decreasing allowances, and then there's a transfer from, which supports all of that. But Keeper, are you having any success at that end?
So I actually minted my own tokens on a specific HCS topic, which is super nice. It was the first time I've ever minted tokens on the Hedera Consensus Service, and I think it took me like 3 minutes to get set up and running. But it seems like I'm having issues connecting to your topic ID. Let me try to run this again.
Okay.
I admit that this is likely my error, as I've never tried to run this demo and sync up to his tokens before, rather than anything else going on here. What is the topic ID that you have here? If you want to.
So the topic ID here is 56414. Oops, sorry.
56414. So I'm attempting to run the join command there and refreshing. And we will see if that works. But in the meantime, it could be great to actually show people where this lives on our GitHub and maybe dive into what that code looks like and kind of compare and contrast it to the Solidity that people either love or have no idea what Solidity is or how it works. So while I'm figuring this out, that could be a great.
Here's one I prepared earlier. So shout out to Greg and others who've put lots of work into making this work. But the code here is, as you could see, is pretty simple. There's not an awful lot going in. We'll dig into it in a moment. Actually, let me make this window a little bit bigger just in the meantime, so we can go through some of this. So you can see, I'm not going to read this word for word. I encourage you all to go look at the this example, this link afterwards. All this code is there for you to consume, hack apart, pull apart, build your own, improve upon. And there's other things that we'd encourage you to plug into this as well. but fundamentally, we're kind of trying to show you the absolute minimal amount of data here, of necessary logic to make a token work. There's lots of almost religious battle that goes on around the token space, and I certainly don't want to get into that. I'm not comparing and contrasting this to any of the existing technologies out there. This at the moment would require quite a lot more work to make it as robust as some of those systems, and it's not intended to be an example of how to go do that perfectly. But fundamentally, every piece of information that we pass through the Hedera network doing this is logged on those Mira nodes, and while those Mira nodes and the data that they store exists, then we'll always be able to go back and do that, and we'll also later be able to look at state proofs and compare and contrast against the original, the Hedera mainnet as well to verify these things. So there's a lot of kind of backing of Hedera behind all of this. Anyway, I'm getting carried away. So you can see some of the operations that we were just going through. You can see the introduction here telling you to set up the env file, which is what I mentioned right at the beginning. And you can see, I didn't even do a balance of, but you can obviously do a balance of and get your balance or get a balance of a particular public key. The refresh you saw is the kind of query and update locally. This is the process to go through and build it. It's really that simple. And yeah, once you've done that, there's a bunch of different tests that you can go through. So I'm not going to read through all of this. You can see and browse this to your heart's content later. If there are any specific questions, then I'll answer them, or at least get Greg to answer them offline.
Yeah, this is a great starting point. You know, we had a question in the chat. Could maybe Donald talk about the cost of requesting a balance and how to get around that? What does that kind of model look like on HCS?
Yeah, sure thing. So I'll let Tim comment, on anything I get wrong. As everybody is aware, I'm sure, the majority of interactions with the Hedera network, transactions or queries have an associated fee with them. That's not true for getting an account balance in HBAR. But one of the big benefits of this model is you can determine your fee model to be custom essentially to your permission network. So say, for instance, you're updating a local state that's kept on your machine. It would just be a matter of checking against that local state to get the balance of an account. And if you want to set a fee schedule or some type of transactions associated with that, that's really the flexibility provided by the Hedera Consensus Service. I'll also say that even for account balances on the Hedera mainnet, account balances of HBAR, you can, again, check directly from the network or use a third-party Mira node that often maintains an update to those account balances.
Yeah. So sorry, Don.
But again, for a token issued using HCS, it'll likely be custom, to your issuance rules and the fee model you want to set up around that token.
Yeah, great question. If I can go into a tiny bit more detail around some of these things that I should really have mentioned earlier in terms of the consensus service. So just looking at this, I've gone into the fee estimator. I'm not really going to run through a lot of this right now. I will go and look at one or two things. But this just highlights the low-level APIs that we're calling behind the scenes here to make all of this work. So we've got create topic, which creates a topic exactly as it says on the tin. There's a few different parameters that we can set there in terms of the permissions to modify that topic, the submission keys on that topic for who can submit to that topic, and some of those have an influence on cost. Some of them don't. They're all pretty minimal. In the testnet, of course, it's absolutely free. The submit message to consensus service I'll look at right here. It, again, depends on the size of the messages here, but if we put 1,000 bytes in here, we're looking at 1/100th of 1 US cent or thereabouts. If we change that to 2,000, we're still at 1/100th of 1 cent. Oops, if I typed right. There we go, we're still at 100th of a cent. So this is not, there's no licensing model here. There's no kind of pay to use this except as you use it. And in terms of getting the data from a Mira node, then that's entirely up to the operator of the Mira node. So when you query the Mira node, when I'm getting a balance, when I'm running these commands here to refresh, it's not talking to Hedera at this point. It's talking to the Mira node. And the Mira node in this case is run by Kabuto, which is not a Hedera at all. So there's no cost to doing that at the moment because Kabuto are nice like that for now. So So there's lots of different pricing models, and we expect to see kind of ecosystem evolving out of this. Don't know if
I really see kind of the speed, the real-time finality of Hedera, as well as this incredibly low cost being some of the main reasons that people should look at tokenization on the Hedera Consensus Service versus, traditional smart contracts, whether they're on Hedera or, another network. The ability to have those fees always be consistent in HBAR and get, guaranteed confirmation within 2 to 3 seconds is very, very appealing, especially to, enterprises and large businesses that need to be able to predict costs months or years in advance. So really, really interesting. I would highly recommend people check out this GitHub repository. It is, available for our GitHub. It is really just a simple demo showcasing how you can map those ERC20 tokens to the Hedera Consensus Service. As Donald and Tim, discussed, and we've chatted about, the Token Taxonomy Initiative is really this larger body and framework for implementing tokens. And you can build those. You can build ERC 721s. You can build just about any type of token out there using this type of project as a reference. And so through these message formats and all the things that Tim's showing here, we make it really, really easy to do so while gaining all of the benefits of using the Hedera public network. I did have another question sent from me in the DMs here. Donald, would you be able to talk a little bit about kind of the access control model on HCS for issuing tokens? Maybe with the context of issuing like a security token or something like that?
Yeah, sure thing. So Tim mentioned topic IDs. That's one of the first comments or components of access control with HCS. So a topic ID can be submitted to or have a message submitted with that topic ID either by a single Hedera account, by a predetermined list of Hedera accounts, which can be added and changed, or by any Hedera account. So it can either be confined to one user or fully public. So what you see in that is you can actually have more fine-grained control in your token support around who can actually submit messages relating to the transfer of those tokens. And then of course, as you saw in the demo, within that token itself, you can have different keys associated with the accounts that hold the balance on the local state, as well as confined to specific rights based on that token. So say for instance, if you're issuing a central bank digital currency, if somebody happens to be from that persona listening to the chat, you'd only want one role issuing that token, and that can vary again depending on the type of use case you're building.
Yeah, that makes a lot of sense. I see a lot of interest in the security token space. It's definitely a market that's rapidly gaining attention. So those are things like issuing real estate tokens or tokens that are asset-backed securities, things where you already have kind of a central party or central issuer that wants to access the greater liquidity, transparency, efficiency that a public network can provide. So having that ability to set, specified parties that are able to create those messages and write these transactions into the topic, like Tim does, anyone who's connected to this topic could be exchanging this token with Tim, which means there's no access controls on it. It's just a public topic. But, in the other world, in the security issuance world or the central bank digital currency world, you have specified parties who need the ability to enforce those permissions and need the ability to say, us and only us, known companies that actually have real estate should be able to mint new tokens to reflect those, real estate properties. So it's really awesome to see that, Tim was showcasing the Hedera Protobuf definitions, which really outlines, how the APIs work. Tim, is there anything you wanted to comment on while we're here?
Yeah, I was just going to draw attention. So we are Protobuf all the way down the stack. So the Hedera root APIs, everything that communicates with our services uses Protobuf. And this is the Protobuf message definition for the creation of a topic. And you can see here that there's a submit key option. And the submit key is precisely for access control of a topic. So you can create a key in Hedera can be a collection of keys or a hierarchy of keys. So you can make that more complex as you choose to. We are multi-sig out of the box on everything. So if you want to create a structure around those keys, you can do that. In reality, we see this as likely to be single keys, except when if you had a consortium, for example, where somebody left the consortium and maybe you wanted to change the key, then you might set 2 keys temporarily just until everybody else confirms that they've got the new key, and then you switch off the old one, and the guy that left suddenly can't talk to your topic anymore. So that's the kind of model. But this stuff's all very well defined in here. I encourage you to go look at poking at these protobufs is the one way to learn absolutely everything about what you can do with Hedera.
Definitely a great resource for anyone who's not familiar. You'll also see similar protobuf message specifications in this token example that Tim demonstrated today, which map to those kind of transactions, that you should be able to see with ERC20 standards, which is a great way to get familiar with the technology and this type of architecture. So I see we have just a few minutes left on this webinar. Hopefully this has been a great overview of Hedera, the Hedera Consensus Service, as well as this demo application for minting ERC20 tokens. I hope that it also showcases or at least elaborates on how you're able to issue different types of tokens using the token taxonomy framework or these other types of demos. Tim, are there any other token demos that you would like to call out on our GitHub, or Donald, that we would like to kind of just put out there if people want to learn more?
So it depends. There are more coming. Some of them are not quite ready for open source, but we are working on a bunch of different projects. That was
a good tease, Tim.
Yeah, yes, yeah. Well, watch this space, yeah, or watch the Hashgraph user in GitHub, definitely. So there are more things coming there. We do have a lot of demos emerging in all sorts of places in that repo. There's some IOU type demos that we did within the settlement demo in SXC, which is the SDK extension components. That's a bit more heavyweight. So when I talked about the kind of hash and signature and proof and all that, we've gone into those things in a lot more detail in there. But yeah, that's when you've got your head around all of this stuff, that's a good place to go and stretch your brain a little bit more.
Yeah, that sounds great. If anyone has questions, we'll be around for 5 or 10 more minutes just answering anything that's going on. Tim, this is a very stripped down demo that really easily showcases how you can mint, burn, transfer tokens in an ERC20-like way. What are some of the questions, or if someone wanted to launch this in a live environment that you would have to kind of solve for that's out of the scope of this kind of basic demo? Do you want to talk about that a little bit?
Yeah, great question, and one of my favorite subjects. So the kind of consistency of execution model is the thing that's really not implemented here. So if you think of a Solidity smart contract, then by definition it runs everywhere, every time. Every time anybody does anything, it runs on every single node. The exact same code runs. That's part of the reason that Solidity is what it is. Now, in this example, we're relying on the fact that the exact same Java code is running on each different machine. And of course, there's ways to misbehave in that are harder to mitigate than using use of Solidity as it is. The way that we've approached this really is that we want to let the user of our platform decide how much they want to enforce those things. So if you take the two extremes, so the Solidity execute everything everywhere, which is absolutely guaranteed, right? It's not going to go wrong. I mean, there's all kinds of things with forking, etc., that we're not going to talk about here. But in terms of its core behavior, it isn't going to go wrong. If you take the opposite extreme, then you trust everything and just hope people behave, which obviously isn't a good model in most circumstances, unfortunately, today. But if you can trust but verify, if you can go and look and say, well, did this person really do what they said they were going to do? Can I go look at the Mira node or Mira nodes? Can I prove this? We've spent a lot of time looking at how we can do that and what the different models are. And if I slide along that scale a little bit, if you look at the Hyperledger model, we've got the endorsement model where you get a few different Hyperledger peers to endorse your transaction before it gets submitted. If you look elsewhere, there are things like the fisherman model where you're incentivizing people to actually to try and find misbehaving nodes. So there's a whole kind of spectrum of different ways to deal with that issue. We're looking at providing the kind of examples of some tooling. This is not product. We're not releasing tokens here. This is illustration of how you can do things with our technology. And I'm excited to see what people will come up with, where this will go. What future will you build is the tagline, and I've definitely drank the Kool-Aid there. So
that makes a lot of sense. Great overview. And back to your original slide deck, this is really how you do native token issuance, or just directly on Hedera. Donald, would you maybe be able to speak a little bit about those kind of other private ledger tokenization options while we have you here?
Sure, and I think to Tim's point, it goes beyond simply private ledgers. When you look at taking tokenization and transactions to scale, you need to have that ability to manage and store your state, to ensure consistency of your smart contracts, be they in Corda, in chain code, which is the Fabric model, or in something like Solidity with Quorum. You could use one of these frameworks to actually bootstrap the building of that token and that network, to do so with the tooling necessary to scale out your token to production, and all using Hedera Consensus Service for a decentralized ordering of the transactions within that network. So in addition to the great work that Tim showed here, that, as Cooper mentioned, is focused on Hedera native, we have those plugins currently available for Hyperledger Fabric and R3's Corda, and Quorum is another one that we're very interested in as well. And you can find all of that either at our Hashgraph GitHub repo, or the Hyperledger lab that we recently had approved by Hyperledger for that integration as well. But it's certainly something we are going to continue to support community development of, and a multitude of options for issuing these tokens as well, all on top of the Hedera Consensus Service.
Awesome. Well, with that, I think that this is actually the conclusion of our virtual meetup for today, unless Donald and Tim had anything else that they wanted to chat about. But I think that the plan would be to, have a few more of these virtual meetups or webinars as those demos that we talked about and other use cases get kind of built out and kind of validated. So this certainly is not the last time that you will see us talking about tokenization on the Hedera Consensus Service. We're very excited about the Hyperledger, Corda, Quorum, and other types of integrations that we have underway, as well as ways that people can build standards and tooling and an ecosystem around this Hedera native type of tokenization. So thank you, everyone, for tuning into the live stream. Thank you so much to Tim and Donald for joining me. If you have any questions about anything that we chatted about today, there is a dedicated channel in our Discord chat at hedera.com/Discord, specifically for the Hedera Consensus Service, where you can ask questions about anything that we have today, or if you run into any issues with the demo applications. So thank you all for joining us, and I hope you have a great rest of your week.